What is up, guys? We're going to be taking a look at this lab, CSRF, where referrer validation depends on header being present. This is a very straightforward cross-site request forgery lab. The objective is to change the email address of the victim, and the backend web app functionality does not require a cross-site request forgery token, but it does require the referrer header on the post request to point back to the web app itself. Now, don't worry too much if that doesn't make sense immediately. Let's fire up the lab. We'll see how everything works. The first thing that we'll do is log in with the valid credentials that we've been given, Wiener, Peter. We're going to simulate a legitimate change email request. Call it new email at email.com. We'll select update email, and in the background, we're going to be harvesting the post request with Burp Suite. So here is a copy of the request. First and foremost, there is no cross-site request forgery token. If we send this, we get a 302 fan response. We're able to change the email parameter in the post request body. This actually sets a new email on the account. Having said this, the root is still somewhat protected because the backend requires the value of the referrer header to be set to the value of the web app. In other words, post requests coming into the web app to change emails must also originate from the web app. This is a problem in the context of a cross-site request forgery attack, where we're hoping that the victim lands on an attacker-controlled domain, because then the referrer header is going to be set to the attacker's domain rather than the domain of the web app. If you're wondering whether we can spoof the value of the referrer header from within the victim's browser, the answer is typically no, or at least it's not straightforward to do so. We would need some kind of other vulnerability in place. In other words, there's actually a built-in amount of cross-site request forgery protection here, despite the fact that the web app is not making use of a cross-site request forgery token. So a logical question we might have, is it okay to protect the web app this way? Perhaps we don't need a cross-site request forgery token, so long as we require the web app to perform some validation on that referrer header. So the general answer here is that relying solely on the referrer header is not considered a secure replacement for utilizing a CSRF token. In other words, it's something that you can do in addition to relying on the CSRF token, but it's not something that you should do exclusively. There are at least 3 reasons why it's not considered a good idea to rely on the referrer header instead of a CSRF token. The first is that privacy settings on browsers may be stripping the referrer header on outgoing requests. So in such cases, you would actually be denying legitimate users access to web app functionality because they don't have the referrer header set. The second reason is that it is possible to spoof the value of the referrer header. As we mentioned, it's not straightforward to do this. We can't just achieve this via HTML meta tags when the victim lands on the attacker-controlled domain, but it doesn't mean that the referrer header is completely unspoofable. For example, it could be manipulated by vulnerabilities, older browser plugins, or even requests made outside of the standard browser. So although it's not easily spoofable, it is potentially spoofable. And then the final reason is that sometimes we simply do not want to include the full URL of the referrer. Perhaps the URL contains sensitive information. We wouldn't want to submit that as part of our header request to another website. So we have 3 reasons why it's a good additional form of security, but shouldn't be relied on as the main form of cross-site request forgery protection. Now, just to give you an example of how this works, if we change the domain itself, let's just strip 1 character from the domain given in the referrer header, we choose send, we now get the response invalid referrer header, refuses to process a request. It doesn't really care about anything after the query string, so it doesn't care if we change the ID to that of a different user. It's purely checking the domain to see if it matches up to the domain of the web app. So it's preventing cross-origin requests. The key vulnerability in this case is that the referrer header is completely bypassable. So if we completely strip this from the request and choose send, we now get a 302 fan response. And if we change the email to something else, let's call it second email, let's dispatch this request, we can confirm that the email is being changed despite the fact that the referrer header is not set. And that's why this lab is called CSRF, where referrer validation depends on header being present. So it only validates the header if it's present. In other words, the backend logic is something along the lines of, if there's a referrer header, check to see whether it matches up to the domain of the web app. But if there's no referrer header, simply continue with the change email request. Now, why is this relevant from the perspective of a cross-site request forgery attack where a victim lands on an attacker-controlled domain? Well, although we can't spoof the value of a referrer header, we can use meta tags to control whether the referrer header is ever sent when the post request is dispatched to the change email endpoint. So if we head to the exploit server, let's see an example of a potential HTML snippet that could be used on the attacker-controlled domain. So we're going to change the page body to a HTML snippet. Now, most of this is a generic cross-site request forgery attack. So we have an auto-dispatching form that sends a post request to the change email endpoint, and we also provide a value. Now notice that some of the templates given by Portswigger have a URL encoded @, which actually breaks the functionality of the request. So we need to replace this with a non-URL encoded @. But the key point is we have part of the post request body containing an email parameter with the value set to the email address we want to set on the victim's account. Then we have the auto-submitting JavaScript. The way that we strip the referrer header from the request is to make use of this meta tag. Meta, name equals referrer, content equals no referrer. And this will strip the referrer header from the request that is dispatched. So although we can't use these meta tags to set an arbitrary domain for the referrer header, we can use it to strip the referrer header. And as we've seen, the web app only verifies the referrer header if it's set. If it's not set, it doesn't run any verification. And since the app is not making use of a cross-site request forgery token, it's possible to dispatch that cross-site request from the victim's browser. And also the victim's browser is going to include that session cookie, which we don't have direct access to as the attacker. Now, just to illustrate the concept here, if we strip this meta tag, let's store the HTML snippet on the page. Let's choose deliver exploit to victim. Nothing's going to happen because when the victim visits the attacker controlled domain, it does still dispatch the post request, but the referrer header is set to the attacker's domain. So the web app looks at the incoming post request, says, okay, this clearly originated from the wrong place. Let's not process this change email request. Whereas now if we replace that meta tag back in to the HTML snippet, no referrer header is set on the request. When the web app receives a request, it looks for the referrer header, sees that it doesn't exist, and then doesn't perform any verification whatsoever. It simply proceeds with the change email request. So if we store this request, by the way, just as a quick recap, I've automatically placed my lab ID here in the action. You need to make sure you set the action attribute on the form to the ID of your lab. This is going to be different for every single user. So let's store this HTML snippet. Let's choose deliver exploit to victim, and we get the flag. Congratulations, you solved the lab. So returning now to the lab description, hopefully it makes a lot more sense. It attempts to block cross-domain requests via verification of that referrer header, but has an insecure fallback. So the fallback is if it doesn't detect the referrer header, it just proceeds with the logic anyway, rather than refusing to process a request. The next takeaway from a mitigation perspective is that we shouldn't be relying exclusively on referrer validation to protect against cross-site request forgery attacks. It's an additional layer of security that we can choose to include, although a CSRF token is sufficient security in itself. So we can use validation of the referrer header as an additional layer of security, but it shouldn't be the only layer of security. It's generally considered a weaker form of security against cross-site request forgery attacks, more prone to bypassing than a CSRF token. From the attacker perspective, anytime we see a web app that's not making use of some sort of CSRF token when we're creating backend changing post requests, then already we should be on high alert. There's probably something not quite as secure as it should be. There may be some security in place, such as referrer header validation, but the absence of that CSRF token is a huge red flag and often an indication that you should keep on prying and digging to see if additional vulnerabilities can be exposed. All right, that's pretty much it for this lab. Thanks very much for checking out the content. Catch you guys in the next lab.